All right, here is the video for the Chapter 3 quadratics test. Now this is going to be a little bit from Chapter 2 in your book. I believe 2.1 and 2.2, and then pretty much all of Chapter 3. So if you want to look through there for some additional practice, you can. The first three questions, I just want you guys to get to thinking of when you enter this first part with all these tables, how do you start to answer them? So you're going to use the factoring or the quadratic formula, which let's write that down, the quadratic formula. And you're going to do this when you are solving for x, okay? And we're going to use that if factoring doesn't work. So you're going to use factoring or the quadratic formula if you have more than one type of x or just one type of x. You're going to use it when you have more than one type of x. I'm just actually going to x that out. And your problem has to be in standard form, which means it goes ax squared plus bx plus c, and then it's equaling 0. Everything's got to be to one side. And you really want this ax squared to be a positive value. So think about that as you have to move things over. You're going to use the square root method, which means you get x by itself when you just have one type of x, and you work backwards in PEMDAS, or order of operations. So that means the order of operations backwards is you're going to do your addition subtraction first, then you're going to do any multiplying or dividing, then you're going to do your exponent, and then you're going to do your parentheses. So PEMDAS, but backwards. And one more reminder, I squared is worth -1 as you go through these. So what I'm going to do in the first part is I'm going to be solving. And if you can factor, I do expect you guys to factor. So let's start with this first problem. I'm going to solve for x, which means I need to look at how many different types of x's I have. I just have one type, so I'm going to work backwards. I do have addition and subtraction, but those are in the parentheses, so I won't get that until the end. So the first thing I'm actually going to move is the exponent. So first I'm just going to square root both sides. And the square root cancels out the square, so I'm left with 3x minus 7. And then over here, I'm just going to leave this as plus or minus the square root of 110. 110 does not have a perfect square root. There's a decimal value. And we'll work through this whole simplifying of the factors of 110 in just a moment. Otherwise, after that, what I'm going to do is I'm going to add 7. And I'm actually going to, when I add 7, I'm going to put it in the front because that's the way it usually is. The radical tends to be last. And then I'm going to divide the whole thing by 13. So let's talk about answers. This is a good answer, technically. You'd get most of the points, but what you should see for the best answer is, does 110 have that perfect square root factor in it? So you would run your factor program, and I'm looking for, do any of these numbers have a perfect square root? And none of them do, so this is as good as it's going to get if we leave it in a radical. If you'd like, what you can do is you can actually take the square root of 110, which is 10.49, rounding, and then give me the decimal answers. So first I would do this problem once, and I would take 7 plus that decimal answer, hit enter, and then divide by 13, and I'll get 1.35. This is rounding to the nearest hundredths. And then I could do this again. I'm going to hit second enter, so I don't have to retype stuff. I'm going to do that twice, and I'll get back to the original one. And I'm going to change that plus into a minus, hit enter, and then divide by 13 again. So my other decimal answer is -0.27. So here's probably the best answer. And then this answer is just as good. I like the decimal one, so if that's what you want to do, you can. All right, number 2, I got to solve for r. So the first thing I want to look is how many different types of r's does it have. It has 2, so that means I need to get it into standard form. And if you can factor, I do expect you to factor. I'm just subtracting the 28 over. And I'm going to take my a, which is 1, a times c, that's -28. And are there factors of -28 that get me to -12? I'd run my factor program. I'll see that 14 and 2 will work, and I'm going to have to make the 14 negative. So when I multiply these, I get the -28. And when I add them, I get the -12. So this is the easy factoring. I'm just going to do r minus 14 and r plus 2. Now you've just factored. You still need to solve. So what's going to make your factor 0? This one's going to be 14, and this one's going to be -2. So here are your answers for number 2. All right, third one, I need to solve. So the first thing I want to see is how many types of x's do they have. There's more than one, so I'm going to try to factor first. 2 times 50 is 100. And I want factors of 100 that get me to 29. I'd run my factor program, and I will see that it's 25 and 4. And the idea of this is this 29x is broken up into those two factors with x's. So I'm just going to rewrite the problem so that I just have 4 terms instead of 3 terms. So I still have 2x squared. Here's 29x. Here's 50. And then I group them. Now, if you don't like this method, if you're afraid you're going to mess up and once you factor you do this, one thing is you should slow down and just double check. If you FOIL this, do you get x squared or 2x squared? No, you get x squared. And if you FOIL at the end, you get 100 and you're supposed to get 50. So if you think you're going to mess up, then do the quadratic formula. Anyway, I'm going to go ahead and group them. And in the first two, I can take out just an x. So that I'm left with 2x plus 25, which is what the other set has to be. And that's going to force me to take a 2 out. So when I'm done, here are my factors. The pieces on the outside, and then the pieces on the inside. Now, again, we still have just factored. I haven't solved yet. So factoring to solving means I need to ask myself, what's going to make my factor 0? And this one's a simple one. This is -2. And if you don't see this one, you're just asking yourself, what times 2 plus 25 gives you 0? So just solve this little math problem. Subtract the 25 over, and then divide by 2. And when I divide by 2, I'm going to get -12.5. So here are my 2 answers for 3. And again, what these answers mean, if I put -2 into this, I should get 0. And I just realized there wasn't a 0 at the end of that problem. All right, next one, I need to solve. So again, how many types of x's do I have? I just have one type of x, so I can work backwards. I can use that square root method. So I'm just going to move the 9, the squared, and the 36. So first, I'm going to move any addition or subtraction. So I'm going to subtract the 36. On this side, I have 9x squared. On this side, I have -36. And now I'm going to divide by 9. And now to get x by itself, I'm going to square root both sides. And remember, we're taking the square root of a negative number. And the fact that we're going to take the square root says we have plus or minus. And that it's a negative number means I'm going to have an I with it. So the square root of 4 is 2, but the square root of -4 is 2i. And that's the answer you should have. This, you won't get the points if you leave your answer as this. Okay, you have to go to this. Number 5, so I see more than one type of x. That means I'm going to factor. And again, I'm going to take my a, which is 1, a times c, and I'm going to look for the factors of 18 that get me to -4. So this one I want you to see on the factor program. And just a reminder, you can only put in positive numbers. And so I'm looking for a set of numbers that will get me to 4. And none of these are going to work, which means you can't factor this problem. So I'm going to put NF, not factorable. So that means you need to go to the quadratic formula. So here, A is 1, B right now is -4, and C is 18. And I'm going to do the quadratic formula. So I'm going to take the opposite of B, plus or minus B squared. So -4 squared is 16, minus 4 times A times C. And I'm going to divide all of it by 2 times A. So all of it divided by 2. And then what I'm going to do is work just inside my square root, which is called the discriminant. And I'm just going to take 16 minus 4 times A times C. And I'm going to get the square root of -56. So answers. This will not be an accepted answer. At the very least, what you need to do is acknowledge that you understand that there would be an I in there and pull that out so your square root of 56 is positive. The next best answer is to see does that 56 have any factors that are perfect square roots? and it doesn't say done, but it is done. 4 works, so 4 and 14. So it would be best if you take that square root of 56 and you break it into 4 and 14. Okay, and then that 4 becomes a 2. So the better answer is this, 4 plus or minus with the 2, then the I, square root of 14 over 2. This is a great answer. Fantastic. If any of you notice, and we talked about this, that you could actually take a 2 out of all of these. If you want to take that step, divide this by 2, this by 2, this by 2, and write this as your answer. That'd be great. But you can leave your answer like this. Or like this, but I'll be honest, you're not going to get as many points if you leave it like this as opposed to this. Okay? So this is the best answer I'm looking for, and if you see this, that's great. That'd be wonderful. All right, number 6. When I look at the problem, I have more than one type of x, but it's not in standard form. So I'm going to subtract that 6x over here because I really want that to be positive. So now I need factors of 7. That'll get me to negative 6. And there are factors of 7, but at this point, it's not going to work because to make this a negative 6, I need this to be a negative 7, and then I don't get the positive 7 up here. So again, this is a problem that, as it turns out, it's not factorable. So I'm going to go into the quadratic formula where a is 1, b is negative 6, and my c is 7. So I'm going to take the opposite of b, plus or minus, I'm going to square that b, so 36, minus 4 times a times c, which is 7. And then all of this is going to be divided by 2 times a, so 2. So inside the square root, this is going to give me 28. And 36 take away 28 is 8. And again, this is an okay answer. It's not all the points. The better answer would be to see that you can take the 8 and break it into the square root of 4 and the square root of 2. And then the square root of 4 becomes a 2. So the better answer would be this. And then again, the next best answer is if you see that you could take a 2 out of all of these, then you'd have 3 plus or minus the square root of 2. So great answer, no, okay answer, good answer, great answer. And if you are more comfortable, turn it into a decimal if you want to find out what that is. If you're going to turn it into a decimal, you could just start at this step. And again, you would just type in 6 plus the square root of 8, hit enter, and then divide by 2, so you get 4.41. Oops. And then you could do 6 minus the square root of 8, hit enter, and then divide by 2, and you can get your other answer, 1.59. Okay, so again, you're going to have to decide if you'd rather do the decimal or if you want to leave it as the radical. Okay, the best answer of all of them is this, and then this one, and then this one. All right, here you're just simplifying, and please realize that you're adding, you're not actually multiplying. So I'm going to add the opposite here, and then adding, you just combine the like terms. So I'm going to add my real numbers, that gives me 1. And then I'm going to add my imaginary numbers, and negative 9i and a 5i give me a negative 4i. And then that's it. You can't combine a real number with an imaginary number. Together, these two make a complex number. All right, let's go to this one. So here I'm going to distribute. So here, this gives me 30i. And then when I put those together, I'm going to get negative 12i squared. And then at the top, remember, we wrote that I squared equals negative 1. So that's just going to make this negative 12 times negative 1, which becomes 12. So when I'm done, I have 30i plus 12. And that is the first page. All right, moving on to the next page. Simplifying. So in the rule of square roots, we want as small of a number in here as possible. So I need to find factors of 75 that have a perfect square root. When I run my factor program, I'm going to see that the square root of 25 and the square root of 3 give me 75, and then there's the negative 1 for the negative number. The 2 is just coming along. These are all multiplied. Square root of 25 is 5. This comes along. It's still all just multiplied, and then this becomes the I. And then the way I would write this is 10. Then you usually put the I next and the radical 3 at the end. Okay? All right, next problem, solve. So again, I have more than one type of x, so I'm either going to factor or do the quadratic formula. If you try to factor, you're going to see that a times c, 10. There are no factors of 10 that will get you to -2, none. So this isn't factorable. So what we're going to do is the quadratic formula. So a is 1, b is -2, and c is 10. So first I'm going to take the opposite of b, plus or minus, then I'm going to take that b and square it. -2 squared is 4. Then minus 4 times a times c, and everything is divided by 2 times a, so 2 times 1. Walking around with people on the homework, some people forget the plus or minus, don't forget that. Anyway, inside the square root, this is going to give me 40, and then 4 minus 40 gives me -36 in here. So this is not an accepted answer. What the very least you should do is realize that you would get an imaginary number here. But the square root of 36 has a perfect square root, so you could find that square root, which is 6, and this is a great answer. But again, sorry about that. You might notice that you can take a 2 out of all of these, and if you take a 2 out of these, you're going to get 1 plus or minus 3i, and then over 1, but you don't need that, so this is the best answer. All right, next one. Write the following function in factored form, then state the vertex. So factored form means I just need to factor this. So what are factors of 64 that get me to -8, or sorry, -16, and that would be a -8 and a -8. And then I'm going to rewrite this. And what you might see is the quickest way to do this is you can actually write this twice squared like that. And then this has become factored form. There's my a. There's my k at the end. And so just looking at it, my vertex is 8, 0. Now if you don't see this, then remember, if you were to graph this, this is where it's going to hit the x-axis. And you would ask yourself, what's going to make your factors equal 0? Well, that would be x equals 8. And since it's twice, you know, that means you're not, 8, and then I could draw it again. But that means the only place this is hitting the x-axis is at the vertex. And the idea, if you put 8 back in here, your y is 0. So there's your vertex, 8, 0, whichever way you see it. Okay, substitution or elimination. I think on this problem, I like the substitution method. With the elimination method, I need y's to line up x's, regular numbers. And with these parentheses here, the elimination method's not going to really work that well. So I'm going to take the fact that y equals this, and I'm going to substitute it into here. So y subs out, the 2x plus 5 subs in. This x plus 3 squared, right now when I start to look at the problem, I'm going to notice that I have more than one type of x. I have an x out of parentheses and I have an x in parentheses. Those are different. So what I'm going to do is take this x plus 3 and realize that it means to do x plus 3 twice. I'm going to FOIL this so I get x squared and 3x. And then that 3x will combine with this 3x, which will give me 6x, and then 3 and 3 is 9. And then I'm just going to bring the rest down. So here's the left side. And then finish the right side. Don't forget my 4. And then I definitely have more than one type of x, so I want to get this all in standard form. So I'm going to bring the 2x and the 5 to join the stuff over here. So before I move it over, this 9 minus 4 is 5. And now to get everything to one side, I'm going to subtract the 5 to this 5, which will cancel out. The 2x is going to subtract over to the 6x, and that will become 0 on the left and x squared plus 4x. And I have more than one type of x. I'm going to factor. I'm going to factor out that greatest common factor of x. And now that's it. I can't factor this anymore. I just want to ask myself what's going to make it 0. So what's going to make this factor 0 is 0. And what's going to make this factor 0 is -4. And I've solved for x. Now, right now, if you looked at these shapes, this is a regular parabola, and this is a line that's going through it. And I have found the x solution. So I found -4, but I don't know why. And I found 0, but I don't know why. So don't think that you're done. You still have to solve for y. So I'm going to take these x's and plug them into either of these. I'm going to plug them into the top one. So let's start if x is -4 into the circled one. Oops, sorry. So this is going to give me -8, and then -8 plus 5 is going to give me -3. So there's my y for this one. And if I put 0 in, I'm going to get 0, and 0 plus 5 is 5. So there's my other answer. So my solutions are 0, 5, and -4, -3. All right, next part. What you have to do is you're going to use the graph and you're going to determine the number of solutions. So how many solutions are there? And then the type of solutions. Are they real or are they imaginary? And if it has no solution, and if it does have a solution, name them as points. So what's the x and y coordinate? So this does have a solution right there. And the scales by 1. So this is just, so 1 solution, and it's 1 real solution. And then the solution is -3, 0. This one, so it's, here's the x-axis, here's the y-axis. This doesn't have any solutions, so it has 0 real solutions. And in